Hey there everybody, this is Nathaniel Lesk here for US, or not for USSW Northern Indiana. That is not who I'm recording for. This is a recording for my YouTube channel, SPCO Steel of 1997. Wow. Today, I have a cool video for you. It is called How Forecasters Forecast Fog, and I'm going to try and start a series where it's going to be called How Forecasters. I'm trying to go more into in-depth weather on this channel. I know it was all weather, then we went to technology, now we're back to weather. I'm going to stick with weather for this one. And if you notice in my voice, I've got a little bit of like a groggy voice. I've been dealing with allergies very bad for the past week or so, but we're getting better, promise. And I am all okay to start to do this video. So like I said, we're going to talk about fog. And I'm going to talk about fog for just a second and what fog is. Fog, basically, you need to have two things. You need to have a temperature, an air temperature at or above 32 degrees, not at, but above 32 degrees, and you need very high humidity and dew point levels. Now, say the current temperature right now in Osceola is 51 degrees. It's quite windy out there and kind of chilly feeling. Anyway, that's a side note. The temperature is 51 degrees. Say the humidity rises to 100%. Then that means your dew point is 51 as well. When when all three of those numbers are right there together, then that means that the air is saturated, which means it cannot hold any more water in the air. Well, that now means that there's going to be fog. It needs to get rid of that in a form of fog. And that means we're going to have these little tiny little droplets of water, and that's what creates fog. Basically, fog is clouds that you see way up in the sky. They drop thunder or heavy rain, hail, freezing rain, sleet, snow. They create lightning, thunder, all these crazy things that go up in the atmosphere, and they come all the way down, except they just don't cause any precipitation. They're just down at the ground. And for fog to usually go away, you usually hear people say, oh, well, the sun will burn it off. Technically, yes, it burns it off, but it's just a fancy way of saying that what will happen is the air temperature will rise, but the dew point will stay just about the same, and as the temperature rises, then there's starting to be a gradient between your temperature and your dew point. When there's starting to be a gradient between your temperature and dew point, then the air starts to clear out, and you get full visibility. So let's talk about graphs here, and what are we looking at right here? And basically what this is right here is basically how forecasters forecasts fog. I don't know why I just said that. But this is how forecasters forecast stuff. Basically what they do is they go onto these different computer weather models, which is the HRRR, the GFS, European models, NAM, NAM-NEST, RAP, and all kinds of stuff. There's all kinds of computer models that are out there. And they'll start to see stuff like this for their forecasts. And this one was from yesterday, Tuesday, April 25th. And this is actually when I made this this presentation. This is how they forecast stuff. So this is where we're gonna be for this lesson and for this for this video. And this over here, and so this red line right here, you see this red line right here, just kind of goes everywhere. That's your temperature, and this green line is your dew point. And now these lines, they go up. So this is 1,000, and these numbers are in millibars. So 1,000 millibars, 850, 700, 500, 300, 200, 100. The farther up you go, the higher up in the atmosphere you go. 100 millibars is probably a good 30 to 50,000 feet into the atmosphere. And 1,000 millibars is right here at the surface where we live, right at the ground where we live. And then you, like I said, you just go up as you go along. Well, these numbers down here, this is the temperature, but it's in Celsius, and then you have your Fahrenheit temperatures down here. Well, you see how kind of right here that this line, as you go up, it kind of goes up. You see it kind of goes up with the numbers and then it shoots down. That means around 700 millibars, or 203 kilometers up in the sky, that means that the temperature and dew point, they're very far from each other, so it's very dry. But if you look at it up here around 200 millibars, so close to 12 kilometers up into the atmosphere, you can see they're much closer together, which means it's much more saturated, but much more moist. Not completely saturated. That would mean that the lines are actually touching or overlapping each other. That's a saturated atmosphere. But it's more moist, so they're closer together. So for fog to happen, you kind of need those lines to be very close together all the way up. Let's take a look at a couple pictures of some fog. Well, here's the fog that we look at around the mountains area. So, like say you're in the Rockies, and you notice how sometimes you're way up into the mountains, and you can see above the clouds. You can see on top of the clouds. That's an awesome view. Well, let's refer back to this graph over here. Okay, so this fog is happening, I'd say right about here, just between 850 millibars and 1,000 millibars. So this top of the fog is right there, but see what happens as it go up, but notice how as it goes up further into the sky, there's no cloud anymore. That is because your temperature and dew point are very far from each other, so it's not saturated enough to really give that fog, that cloudiness. So that means below this cloud layer right here, below it, the atmosphere, the air is completely saturated. You go up and it's dry. It's drier than saturated, but it's dry. And that's how sometimes we can get some cap, and that's what we call a cap. And that cap is capping off that humidity between the humid air and the dry air. And usually that's kind of how it is with thunderstorms. Some forecasters talk about a cap in the atmosphere, and it separates the really warm, humid air from the dry and much cooler air aloft. And when that cap breaks and you let that warmer air just really explode up into that atmosphere, you can get storms to fire off like that. And so this right here, rather they're not getting storms under this cloud layer, that still gives you a representation of a cap off of what happens between a really saturated layer of the atmosphere and a very dry section of the atmosphere. So let's talk about this fog. You can kind of see here where you see like there's snow possibly right here. You got some snow on the ground or maybe on the trees. That's rather more ice crystals than snow. I know everybody thinks ice crystals are it's snow anyway. But in this case, it's not from snowfall. This is what we call freezing fog, or also inversion fog. And we all know the term inversion, right? It means when you have one set of numbers it completely flips, right? So let's say you have a positive 10 number and then you get a negative 10 number. That means they're inverted. It's the complete opposite of each other. So this is what we call inversion fog. Well, I'm going to go back to this graph. I made these guys. This is completely made up. This is the first picture of the mountain fog. Notice down here, you again have these lines that are very close together. Remember we talked about the red line is your temperature and this green line is your dew point. Notice how right here at the surface, they're right next to each other, but they quickly split off, and the temperature goes up and the dew point goes down. That's where that capping comes off of. Let's take one more look back at the inversion fog. There we go. This is the inversion fog, and like I said, ice all over, and you can see it's very foggy. This is what happens when you get inversion fog or freezing fog. Notice how your dew point and temperature lines are right next to each other, but look how this is happening. You have temperatures down here. Now remember, I put these temperatures in Fahrenheit. These are in Fahrenheit, not Celsius. Remember, Fahrenheit, not Celsius. I don't want to make you guys go confused. I put these in Fahrenheit to make it easier. Notice how they go up, and then the lines go up, but they're all really close together. That would indicate that there's a very saturated atmosphere from all the way at 9,000 feet all the way down to the surface. Okay? But you notice how down here, where the temperature is right below 20 degrees, so probably anywhere from 17 to 20 degrees, 17 to 19 degrees Fahrenheit. And notice how the temperature actually goes down slightly, stays the same, but bam, it shoots way up, and we're up almost to freezing. that means that these temperatures are completely flipping. So we got a really high temperature up here compared to what's going down at the surface. So what that means is that we can get some fog to happen. Now, I'll give you a little bit of science. Water can actually be cooled to 10 degrees Fahrenheit and not freeze. You're probably looking at this video saying that is complete bullcrap. No, it is not. I want you, whoever's watching this, I want you to go, if you have a bottle of Pure Life, Dasani, Aquafina water that's purified, or you have a water filter, a pretty good water filter, fill a water bottle up with water, but don't fill it up all the way. Fill it up to where there's about this much air left. And then put it in your freezer and do not touch it or let it move for the next 4 to 6 hours. Or you could even let it go all night long. And what will happen is you'll probably open it up and find it's still in liquid form. Freezers have to be at least 0 degrees Fahrenheit because of food safety standards. They have to be at the warmest 0 degrees Fahrenheit. But they're way lower than that. So probably anywhere from -1 to -10 degrees Fahrenheit. That's a freezer. I know there's some freezers there's like 5 degrees, but that doesn't stay there for very long. So usually it's 0 to 10 degrees Fahrenheit, 0 to -10 degrees Fahrenheit. That's very cold. So think about it. That can be super cooled. That's what's called super cooled water. And I'm telling you, if you open up your freezer, you immediately start moving that water, it's gonna freeze like that. Because all the molecules you have, remember your water molecules are H2O, one element of hydrogen and two elements of hydrogen and 1 element of oxygen. And when you put those two together, you get water. Those molecules are not moving anymore because of that cold air. But they're not frozen until you move it. And that's when they move and realize, oh my gosh, it's below freezing. So then they freeze like that. But if you have dirty water, it'll freeze very quickly because you have pollutants in there that are moving along in it to keep those molecules moving, and it eventually will freeze. That's why you need purified water to do that experiment, right? So remember, water can be super cooled to 10 degrees Fahrenheit. After that, it's done. It's frozen. So what you need to do, so why we call it freezing fog is because, let's go back to this, you find that there's ice all over the trees, all over this fence bar right here, maybe a deck bar, and then this is a fence and all over the ground. You get these glazes of ice because those really tiny super cooled water droplets are hitting the surfaces that are below freezing. And when they hit that, they move and they immediately freeze. That's why freezing fog can sometimes be just as dangerous as freezing rain. Remember, freezing rain comes from the clouds as regular liquid rainfall, but once it hits the surface that's below 32 degrees Fahrenheit or 0 degrees Celsius, it freezes, and that's why they call it freezing rain, because it freezes at the surface. So remember that that's how forecasters forecast fog, is what's the temperature like from the very top of the atmosphere to the very surface, and if the dew point and humidity are pretty close to each other. I want to thank you guys for watching this segment of How Forecasters. I'm going to hopefully have more on the series. This has been a production of SBC OCL 1997. Follow me on Twitter and Instagram at Nathaniel Lusk, and also on Facebook, Nathaniel Lusk. And you can find me Snapchat at Nathaniel Lusk. And I will see you guys in the next video. Have a good day.